All right, so I'd like to introduce our next presenter for this session of elevator pitches. She's Anastasiya Bosova. She's going to talk to us about urban design guidelines for low carbon cities. So Anastasiya is a master's student, as well as Emmanuel, writing her thesis in the MuSES project at the Future Cities Laboratory. She holds a bachelor degree in environmental engineering from ETH Zurich and is currently pursuing her master's degree in integrating building systems. Her current research is focused on deriving heuristics for low carbon district design to inform decision makers at the early design stage. All right, welcome Anastasiya, the floor is yours.
Jimena, thank you for the introduction. And again, my name is Anastasiya Bosova, and I'm currently being half through my thesis. And shortly I will introduce you into the topic of my thesis and share my preliminary results with you. So let's start with the background. Nowadays, there exists emerging need for planning low carbon districts. But the urban planners and architects are still experiencing the lack of guidance in the early design stages that would provide them with some rules of thumb to facilitate the design process. Many guidelines for tropical climate address the environmental performance of the district, such as outdoor comfort, but few of them explore and quantify the interdependencies between urban design parameters and energy performance of the district. From the recent studies, it is known that certain urban design parameters show higher correlation with district energy performance than other parameters. So the largest impact has been observed for such parameters as floor area ratio, aspect ratio, orientation, street width, and building height. However, this knowledge is fragmented and insufficiently quantified to come up with the design heuristics. And the goal of my thesis is to fill in this knowledge gap and provide decision makers in the early urban design stages with such heuristics. So, keeping the most impactful parameters for energy performance in mind, the following scenario matrix was constructed. It contains 4 dimensions that potentially influence operational emissions by affecting energy demand or photovoltaic potential of the district. First of all, these are building typologies that follow classification systems used in the energy-driven urban design studies. Some examples are shown here on the left, and these are podiums, courtyards, X-shapes, and so on. Second of all, the matrix includes land use mixes that is known largely affect energy demand. Third of all, matrix addresses urban form parameters that include density, expressed as floor area ratio, and compactness, expressed as street width. The performance indicators for these scenarios are operational CO2 emission intensities and share of renewable energies that are calculated with an energy simulation tool, City Energy Analyst. City Energy Analyst allows to conduct simulations for thousands of scenarios in a decent period of time. So the total number of districts I simulate reaches 10,000. As for the supply systems, given the goal of achieving low carbon performance, the set of technologies that was chosen is constant. These are district cooling systems and photovoltaics installed on the roofs and facades with the threshold of 400 kilowatt hours per square meter per year. And the rest is supplied from grid electricity. Just to visualize, this is how the urban forms vary within given density. In this case, floor area ratio, that in this example is equal to 10. The plot is located in Singapore, and 25 buildings of same typologies, in this case slab, are placed on the plot. Given the constant plot size and site coverage that are typical for Singapore, here is the visualization how these districts will look like. The wider the streets are and the lower the compactness level is, the buildings get higher, but smaller in terms of its footprint area to achieve the same floor area ratio. Such districts are constructed for different floor area ratios and different building typologies that were shown in the previous slide. So let's have a look at the preliminary results. The results were obtained so far for 4 building typologies: slab, cross, podium, and courtyard. And the results suggest that the CO2 intensity is mostly influenced by land use mix, while the urban form plays a minor role in the current setting. You can see on the graph around the average CO2 intensity for the simulated scenarios, the uncertainty band is fairly small for the whole sample, but the impact of the land use mix on the horizontal axis is significant. Not surprisingly, the lowest CO2 intensities can be achieved if share of retail and office is kept low. You can see it on the left part of the graph. In the following experiments, the mixed settings containing buildings of different typologies within a building block, for example, podium and 2 cross towers or slabs, are to be investigated to introduce variability into urban form and to investigate as many as possible configurations. In the end, we hope to create a catalog for different configurations that would contain quantification of the district performance with respect to greenhouse gas emissions and renewable energy share. In this way, it will be possible to identify best combinations of design parameters to achieve low carbon districts. The expected outcome would be also to identify important trends and concerns that emerge from the choice of building typologies, land use mixes, and compactness levels, as well as the interdependencies among them. In this way, the findings will help to facilitate the design process and to inform decision makers at the early design stage on relevant heuristics for the design of low carbon districts in the tropics. With that, I'm looking forward to your questions and thanks for your attention.
All right, Anastasiya, thank you very much for that. So let's see. We don't have questions at the moment. So I can invite the panelists to give also some questions to Anastasiya. Perhaps I can have one. And I'd like to know more about this concept of understanding that only the land use mix, but not the urban form, can impact the CO2 emissions. What do you think that needs to be? I mean, I think it's preliminary conclusions, but it still gives you some indication of what to expect once you implement different forms in this context of Singapore. What would you expect to happen perhaps in other contexts? Do you have some intuition about that?
I think that it's very important to keep in mind how the district that I analyze look like, and this is mostly homogeneous setting. And I think that if the buildings of those typologies are placed into heterogeneous settings, the results will be very much different due to the difference in solar radiation. Because the shadings will be different from the different angles given different heights in the urban context. And this is one point. And another point is that the current study is placed and located in Singapore. Of course, the parameters that will largely affect the results will be the angle of the incident radiation. So if we change the location of this study, keeping it in tropics, but let's say locating it to Bangkok, where the sun falls with a different angle, probably the distribution of the radiation will be different in comparison to Singapore, because in Singapore it's pretty much straightforward. The distribution between the rooftops and the facades is more or less constant along all the studies. And I guess that in Bangkok, the distribution of the facades will be different. So it will be interesting to see how it would impact the overall picture in the end.
All right. Thank you very much for that, Anastasiya. All right. We have time for, I think we are about time now, actually. Yeah. But we could have actually room for one other question. Maybe the panelists have for Anastasiya.
So thanks, Anastasiya. You mentioned at the end this idea of a guidebook. How do you imagine could planners pick up this knowledge? Do Do you think this is only possible with like these type of tool sets, or could this be generalized in a way that it's more applicable even if you're not a software specialist?
I think that for sure it is applicable because I am able to generate many graphs that contain the valuable data. In my opinion, for the planners, it is very easily readable from those graphs. For example, given certain typology, you can get let's say uncertainty band within which the values for the energy demand and as a result for CO2 emissions are located for different land use mixes. So if urban planner knows that his building is going to look like a cross, let's say, but he's not sure yet what is the percentage of the residential or commercial or retail in this setting, he can check the uncertainty bands, and he can also check the trade-offs between the different land use mixes, because what was observed that the slope changes slightly from one mix to another. So the trade-offs are different between, let's say, increasing the residential by 10% in one mix or increasing it by 10% in another mix where office and retail values are different. So it's interesting to see these trends.
Mm-hmm. Thanks.
All right, we have one question. We have time for that from Ben. Ben asks Anastasiya, how does the relationship of greenhouse gas emissions intensity with building use ratio scale? For example, will a hypothetical city that maintains a ratio throughout all its districts achieve similar greenhouse gas intensities?
I didn't really understand the question. I will have a look at it again so that I can read it.
Sure.
How does the intensity? Well, given the preliminary results that state that the urban form is not that important, but land use ratio is actually a significant factor, then we can assume that this hypothetical city that has even different urban typologies within different parts, it will maintain the same building use ratio, and it will scale depending on the areas as well that are present in the city. So yes, the answer is yes to the question.
All right, thank you. We have another question. The last one is, do you also investigate, by Matthias Ulsa, do you also investigate variables which are of a general nature? For example, use mix has the same effect in all climates?
I haven't looked at different climates yet because the topic of my thesis is actually concentrating on the tropical climate, but it's an interesting point to address. So for now, I'm just looking at the Singapore.
All right, that pretty much answers that at this point. Okay, fantastic. So thank you once again, Anastasiya. Thank you very much.
Thank you.